So today we are beginning with the sedimentary rocks. Okay, the sedimentary rocks. Petrology has been divided into three types: igneous, metamorphic, and sedimentary. We have completed the igneous part of this syllabus. Now we'll be moving towards the sedimentary part. Okay, and this sedimentary part is very much important for us. Why? Because of the hydrological properties and the porosity, permeability of the rocks, which hold sufficient amount of groundwater. Okay, so what we have to study is the what are the sedimentary rocks. Okay, what are the sedimentary rocks and their classification. Okay, the sedimentary rocks and their classification. So what are sedimentary rocks basically? Sedimentary rocks. Sedimentary rocks are those which are formed due to sediments. Now, these sediments will undergo weathering, erosion, then deposition and lithification. Okay, these processes, all these processes will give rise to a sedimentary rock. Okay, the sedimentary rocks are also called as the secondary rocks. Okay, sedimentary rocks are also called as the secondary rocks. Why secondary rocks? Because they are these sediments or the sediments which are which constitute the sedimentary rocks. Okay, which constitute the sedimentary rock, they are derived from some other rocks, right? They are derived from some other rocks. So their parent rock, okay, parent rock for these sediments can be anything. It can be igneous, it can be metamorphic, it can be sedimentary itself, right? It maybe the sediments might be derived from the igneous rocks, sediments might have been derived from metamorphic rocks, sediments might have been derived from sedimentary rocks themselves. Okay, the pre-existing sedimentary rocks themselves, right? So they are just the sources of sediments for the sedimentary rocks. Okay. Got this? Got this? Now we'll be moving towards the classification. Okay, this is just the basic of sedimentary rocks and their definitions. Okay, we'll be moving towards the classification. Okay. Now, the classification of sediments and sedimentary rocks. The classification of sediments and sedimentary rocks, right? Now, the sediments and sedimentary rocks, they are classified on the basis of their materials. Okay, they are classified on the basis of their materials with which they are constituted. Okay, the materials with which they are constituted. Now, these materials, okay, these materials can be terrigenous. Okay, this can be terrigenous, which is called as clastic material. Okay, this can be clastic material, or this can be carbonate material, right? It can be terrigenous, it can be clastic, it can be volcanic material, it can be anything, right? So let us see them one by one. The first one is the clastic or terrigenous materials. Okay, the clastic or terrigenous material. Now, what is clastic material or what is terrigenous material? Clastic material is that material. The clastic material is that material which is made up of particles or clasts derived from pre-existing rocks. Okay, so there was a rock, say suppose This is any rock, rock of any composition. Okay, rock of any composition, rock of any origin, and these rock has been acted upon by the natural agencies. Okay, this rock has been acted upon by the natural agencies, and these natural agencies have weathered the rock. They have weathered the rock, and these rocks, these weathering products, okay, they have been carried along with the natural agencies along with them, right? So might be with the river, might be with the wind. Okay, the sediments have now been transported from their place of origin to some another place. Okay, these materials, okay, these materials which are derived from what these kind of pre-existing rocks, okay, these pre-existing rocks will be called as clasts. Okay, they will be called as clasts, and the rock which is formed, or the sediments, these sediments, they are called as clastic sediments or siliciclastic sediments or detrital sediments. Okay, they will be called as detrital sediments. Okay, and the rocks finally formed due to such clasts will be called as clastic rocks. Okay, they will be called as clastic rocks. Clastic and non-clastic, you might have heard these terms. Okay, so that is called as the clastic rocks. Okay. So what clasts are? The clasts are principally detritus eroded from the bedrock and commonly made up of largely silicate minerals. Okay, why largely silicate minerals? Because majority of the earth contains the silicate minerals. Okay, majority on the earth's crust we have the silicate minerals. Okay, now these terms detrital sediments and siliciclastic sediments are also used. Okay. So sandstones and conglomerates. Okay, the sandstones and conglomerates make up 20 to 25% of sedimentary rocks in the stratigraphic record. Okay, and mud rocks are 60% of the total. Okay, what are these? We'll be dealing with these terms in coming in the course of this class. Okay. Next. So this is clastic materials. Okay, these are the clastic material or clastic rocks. Next is carbonates. Okay, carbonates. So carbonate means which contains calcium carbonate, CaCO3. Okay, a rock or the particle which contains by far larger amount of CaCO3, and how much? Over 50%. Okay, it should have more than 50% CaCO3, just like the name of the rock is, if such rock is there, okay, the name of rock, so limestone. Okay, limestone. If there is a limestone, that limestone contains more than 50% of calcium carbonate. Okay, so this calcium carbonate or these carbonate materials, okay, these carbonate materials, they are the results of chemical weathering. Okay, carbonates are the result of the chemical weathering. Okay, now from where do the carbonates come? Right, if the carbonates are there, there should be a source. The source is the hard parts of the organisms. Okay, the hard parts of the organisms, the hard parts of the organisms which have the sedimentary rocks, basically they carry organisms because of the natural agencies. Okay, and eventually when these organisms die, they are buried under the sediment themselves, and these sediments, they compress this, right? They compress the hard parts of the particles, and they derive the calcium carbonate with the chemical weathering from the organism themselves. Okay, so mainly invertebrates, majority of the invertebrate shells. Okay, majority of the invertebrate shells are made up of calcium carbonate. Okay, it is made up of the calcium carbonate. So such organisms, okay, such organisms, these contribute much to the CaCO3 content. Okay, they contribute much to the CaCO3 content of the rocks. right? What is? Now see this in this chart. Okay. In this chart, the complete classification of sedimentary rocks is given. Okay, complete classification of sedimentary rocks is given. So the sedimentary rocks are classified into two types: clastic and non-clastic. Okay, sedimentary rocks are classified into two types: clastic and non-clastic. Okay, so in case of clastics, we have volcanic clastics, terrigenous clastics. Okay, carbonates. Carbonates, they come under clastic, non-clastic both. Okay, so here volcanic clastics, tuffs, ignimbrite. In clastics, we have terrigenous clastic, so mud rocks, sandstone, then conglomerates. In the carbonates, we have the limestones. Okay, so this is the classification. And in non-clastic, we have coal, then ironstone, then phosphate, then siliceous deposits. Coal is basically not a rock. Okay, coal is basically not a rock, but for the sake of our understanding, we consider it as a rock. Okay, and evaporites. Okay, the evaporites, right? So here in this chart, the principal components of all these rocks are given. Okay, the principal components are given. Kindly go through this. So the mineral grains, different rocks may include quartz, then mica, feldspar, calcite, etc. Right. In the terrigenous, there might be lithic fragments. So different rocks may include the parts of limestone, then mudstone, volcanic rock, metamorphic rocks, etc. Right. So these are the or this is overall classification. This is overall classification of the sedimentary rocks. Now let us see in details. Let us see all this in the details, right? So first we'll study about these terrigenous clastic sediments. Okay, the terrigenous clastic sediments. Okay, so terrigenous material means the clastics material. The clastic material, sedimentary rocks, which are lithified sediments. Okay, lithified sediments. So the lithification is the process of turning into a rock. The entire process, right? The entire process of conversion of sediments into the sedimentary rock. Okay, the entire process of conversion of sediment into a sedimentary rock is lithification, right? So during this, all the particles will not be of the same size. Okay, all the particles will not be of the same size. There will be different size of particles. There will be different grades of particles, and these particles, they will come together and they will form one rock. Okay, they will form one rock. Okay, so here mud, silt, and sand are the aggregates. Okay, these are called as the aggregates. That is the material which is coming together to form a rock. Okay, and then there is a suffix attached which is called as stone. So it becomes mudstone, siltstone, sandstone, etc. Okay. Now, so these materials are given different names. Okay, these materials are given different names. Now there is one scale. Okay, there is one scale which is called as Wentworth scale or Wooden Wentworth grade scale. Okay, this Wooden Wentworth grade scale. This is the scale, right? This is the scale, the Wooden Wentworth grade scale. In this, the materials, okay, the materials are classified according to their sizes. Okay, the materials are classified according to their sizes. Okay, so here mm, then phi value and name of the particles. So if the material is having the radius of 250, okay, it has the size of 256 mm, which has the phi value of -8, it will be called as boulder. Okay, it will be called as a boulder. if it falls into this range 16 to 256, okay, 16 to 256, it will be called as kubel. 16 to 256 millimeter. Okay, so -4 to -7. Okay, -4 to -7, it will be kubel. Then 4 to 16, it will be pebble. Then 2 to 4 granule, 1 to 2 very coarse sand. Then 0.5 to 1 is coarse sand, 0.25 to 0.5 medium sand, and so on. Okay. So this is the classification, or this is the grade scale. Correct. This is the grade scale which is given by the Wooden and Wentworth. Okay, Wooden and Wentworth. Now, this grade scale is a logarithmic scale. Okay, this grade scale is the logarithmic scale. Okay. So it is based to the 10. Right. So how to calculate the phi value? How to calculate phi value? With this formula. Okay, with this formula, you might encounter with a question. Okay, you might encounter with a question. Calculate, or what is the phi value of a grain with diameter any mm. Okay, with a diameter any in m. Just like for a sample question. Okay, just for a sample, take any value, say 2. Okay, take any value 2, put it here. Okay, so phi minus log 2 to calculate, right? And what you have to do is to calculate this, right? Calculate this. So automatically it is going to be 0.25. Okay, it is going to be 0.25. But yes, they can ask you for anything. Okay, they can ask you for anything, and obviously it is not possible for you to remember all these in sequential matter. If yes, well and good. Okay, if yes, if it is occurring that you can remember entire phi values with all these things. Okay, phi values and mm scale, well and good. If you can't, just you remember this formula. Okay, just remember this formula and you can calculate them accordingly. Okay, you can calculate them. So this is the phi value. Okay, so here 4 basic divisions are recognized. Okay, 4 basic divisions are there. The first division is clay. Okay, the first division is clay, which is less than 4 micrometer. Okay, which is less than 4 micrometer. So the particle size here, okay, the particle size here should be less than 4 micrometer. That means you cannot even distinguish between the two different grains of a clay, right? You cannot distinguish in by naked eye, obviously by naked eye you cannot distinguish. Yes, if you want to distinguish, you have to go for microscopic studies. Okay, then silt coarser than that of the clay. Okay, coarser than that of the clay, 4 micrometer to 63 micrometer. Obviously this will also this won't be also be recognizable by the naked eye. Okay, then comes sand, coarser than the silt. Okay, coarser than the silt, 63 micrometer. Okay, 63 micrometer, that is 0.06 mm to 2 mm. Okay, to 2 mm. Okay, this will be your sand. Okay, whatever material falls into these size range. Okay, whichever material falls into this size range will be called as sand. And then the last one is the gravel or aggregates, which is anything which is more than that of the 2 mm diameter. Okay, which has the size of more than 2 mm, right? So this is the Wooden Wentworth grade scale. Okay, this is called as Wooden Wentworth grade scale. Now, what you have to remember here is these classifications. Okay, these divisions or classification and this scale. Obviously, this formula. Okay. Next is the conglomerates. Okay. The conglomerates. Now, I have told you yesterday itself about the conglomerate. So clasts over 2 mm in diameter are divided into granules, pebbles, cobbles, and boulders. So consolidated gravel is called as conglomerate. Okay, the consolidated gravel is called as conglomerate. So they can be of any sizes. Okay, they can be of any size which is falling in these categories. Okay, which falls in these categories: granules, pebble, cobble. It should be larger size. Okay, it should be a large sized sediment. Okay, it should be a large size sediments, and they should be consolidated and should be lithified, right? That will be called as a conglomerate. Here the speciality of the conglomerate is the rounded grains. Okay, such kind of rounded grains are present. Okay, rounded grains are present. So this rounding is important while we are discussing about the conglomerates, right? So these conglomerates, okay, if most of the clasts are between 64 to 256 millimeter in diameter, it will be called as cobble conglomerate. Okay, it will be called as cobble conglomerate. Now similarly, there is something called as brachia. Okay, there is something called as brachia. Now what is brachia? Brachia is any conglomerate, right? Brachia is any conglomerate which is made up of clasts that are angular in shape. Okay, angular in shape. Now here angularity comes into picture. The grains will be like this. Okay, the grains will be like this. This will be conglomerate, and this is for brachia. Okay, this is for the conglomerate, and these angular fragments are for the brachia. Okay, so anything, any kind of material which is angular in nature, okay, angular in nature, which is present in a conglomerate, will form a brachia. Okay, it will form a brachia. Okay, so this is in this picture on your screens, you can see here there is a brachia. Okay, now brachias or the conglomerates. Okay, brachias or conglomerates, they are the amalgamation of variety of clasts. Okay, variety of clasts and variety of the size particles. Okay, so these are classified, or these are further classified on the basis of their origin. Okay, on the basis of their origin. So if all the clasts are of same material, okay, if all the clasts are of same material, so same material, okay, similar kind of materials of clasts are present, then the conglomerate is considered to be monomicte. Okay, monomicte, right? What is monomicte then? Monomicte is a conglomerate which contains the particles, okay, which contains the particles which are of the same material. Okay, then polymicte is a conglomerate that is many different lithologies, okay, which contains many different lithologies, right? So more than 2 3 4 different types of clasts might be present in a polymictic conglomerate. Okay, in a polymictic conglomerate. And in the oligomicte, okay, oligomicte is where just 2 or 3 class types are present, not more than that. Okay, just 2 or 3 class size are present, not more than these 2 or 3 classes. It will be called as oligomicte. Okay, it will be called as oligomicte, right? Now on the basis of the textures, they are also called classified. Okay, the if it has the matrix. Okay, if it has the matrix. What is matrix? Matrix is nothing but the mud. Okay, mud or such materials, Okay, mud or such material which binds the clasts. Okay, which binds the clasts, because there are larger grains, larger boulders which are present. Okay, there are larger boulders are present, and these boulders, okay, these boulders must be bound with something, right? These boulders must be bound with something, and this binding of any rock, okay, this binding of any this binding material in any rock will be called as the matrix. Okay, it will be called as the matrix. Now, if there is high proportion of matrix which is over 20%, okay, if it is called, if it has more matrix, that means it is more than 20% of matrix is present, the rock will be called as sandy conglomerate or muddy conglomerate. Okay, the rock will be called as sandy conglomerate or muddy conglomerate. Okay, now there is again one name which is called as intraformational conglomerate. Okay, intraformational conglomerate. Now this intraformational conglomerate means what? The intraformational conglomerate is the clast is composed of same material as that of the matrix. Okay, so the matrix and this clast, okay, matrix and the clast are of same material. This is same materials are present, right? So this is formed by the reworking of lithified sediments after deposition, right? That will be called as intraformational conglomerates. Okay, intraformational conglomerates. Okay, so this will be matrix supported conglomerate. Okay, matrix supported conglomerate. Okay. If more clasts are present, okay, if more clasts are present, it will be called as clast supported conglomerate. Okay, it will be called as clast supported conglomerates, right? Now you can see here in this triangular diagram, okay, in this triangular diagram, there are the names are given. Okay, some of the names are given here. This apex is of mud, this apex is of sand, and this apex is of gravel. See, these are nothing but the sizes of the particles. Okay, the sizes of the particles which are present in a sedimentary rock. Okay, so here gravel. So when almost 100% or 80 to 100% gravels are present, it will be conglomerate. Okay, it will be conglomerate. 30 to 80% it will be muddy gravel. Okay, muddy gravel, that means mud supported or matrix supported conglomerates, muddy conglomerates. Okay, here muddy or sandy gravel or muddy or sandy conglomerate, because sand is also coming. Okay, mud is also there and sand is also there, right? And here it will be called as sandy conglomerate. Okay, because the amount of mud is almost negligible. Okay, here the amount of mud is almost negligible, right? Now here gravelly mud rock, because gravel is less in number, so whatever is less in number we will use that as the prefix. Okay, whatever is less in number we use it as the prefix, right? So gravelly mud rock, because mud is dominant here, mud is a dominant part, gravel is not that dominant, and hence it is used as a prefix, and gravel there it will be called as gravelly mud rock. And here gravelly muddy sandstone, because mud is also there, sand is also there, and gravel are also there, but gravel is least in number, mud is less in number, sand is dominant. Okay, here gravelly sandstone, again gravel is negligible. Okay, now here where there is almost 100% mud, it will be mud rock. This field is for sandy mud rock. This field is called muddy sandstone, because the mud is now getting converted to sand, or it is now getting transformed into sand. And here almost 90 to 100% sand is sandstone. Okay, this will be sandstone. So this is the nomenclature. Okay, this is the nomenclature which is used for the mixtures for the sediments. Got this? this triangle or this triangular diagram. समझ में आ रहा है क्या? That's what I'm talking about. Because सो गए करे सब लोग?
नो सर।
सुन रहे हो ना? मुझे लगा सब लोग सो गए, कोई बोल नहीं रहा है, कोई रिप्लाई नहीं दे रहा है।
सर सुन रहे।
चलो ठीक है, आगे बढ़ते हैं। Now coming towards the sand. Okay, sand and sandstone. Now what is sand? I just told you what is sand. Right? Sand is defined as the sediment consisting primarily of grains in the size range of 63 micrometers to 2 mm. Okay, 63 micrometers to 2 mm. This is mu m and this is 2 m. So 0.0063. Okay, 0.0063 mm. Right, 0.0063 mm. So 63 micrometer to 2 millimeter. That will be called as sand. Any sediment, right? Any sediment. It need not to be sand which is used in construction. Okay, it need not to be sand which is used in construction. Mind this. Okay, सिर्फ उसी चीज को sand नहीं बोलते, ठीक है? सिर्फ उसी चीज को sand नहीं बोलते. Sand is the particle classification. Okay, it is the particle classification, right? So it is any material, okay, any material which falls in this range. Okay, any material which falls in this range will be called as a sand. Okay, and the rock or sedimentary rock which forms by the lithification of this size range, that is lithification of sand. Sand से बना हुआ rock, sandstone. Okay, sand से बना हुआ rock, sandstone. That's it. Now, the size range is divided here into 5 intervals: very fine sand, then fine sand, then medium sand, then coarse and very coarse sand. Okay, in the wooden Wentworth scale, these classifications are given. Okay. In the wooden Wentworth scale, you can actually see this kind of this classification. Okay, so there is a rock, okay, which contains almost 100% sand. Okay, 100% sand. Although many quartz sandstone contains mainly quartz grains. Okay, it contains quartz grains, right? Because we know that sand is made up of quartz. Okay, the sand is made up of quartz, the construction sand. Okay, so majority of the sandstone, they contain majority of the quartz. So it does not have any implication the amount of quartz present in the rock. Okay, it does not have anything to do with amount of quartz, right? In case of igneous rocks, okay, if you remember, in case of igneous rocks, we have devised acidic and basic. Okay, acidic and basic on the basis of percent of silica. Okay, on the basis of percent of silica. More the amount of silica is present, the rock becomes acidic. Lesser is the amount of silica, rock becomes basic, right? Now, this was the scheme of classification for igneous rocks. Okay, this was the scheme of classification for igneous rocks. Now, in case of sedimentary rocks, Okay, in the case of sedimentary rocks, it does not matter. Okay, it does not matter whether the rock contains quartz or not. Okay, whether the rock contains quartz or not, it is not at all required. So sand is just any particle. Okay, sand is just any particle which falls in this range. Okay, and the rock containing these sand will be called as sandstone. So there might be a sandstone which does not contain any kind of quartz. Okay, there might be a sandstone which does not contain quartz. This is called as arenites. Okay, that is called as arenites, right? So this is the scientific terminology, not just sandstone, but the arenites should be, this word arenite should be used. Okay, now what is this arenite? Arenite is the sandstone with less than 15% of the matrix. Okay, which contains less than 15% of the matrix. What is matrix? Matrix is the binding material. Okay, matrix is the binding material. Okay, so which contains less than 15% of the matrix will be called as arenite. Okay, will be called as arenites. Right. Now, the most important diagram in the classification of igneous rocks, classification of the sedimentary rocks. This is the most important diagram. Okay, you have to draw this diagram. Not now, obviously. If you are drawing, very good. After the class, draw this diagram. Okay, draw this diagram and learn it thoroughly. This is called as the Petitjohn classification. Okay, this is called as the Petitjohn classification for the sedimentary rock or the sandstone. Okay, of the sandstone. There is something dots classification as well. Okay. Now, here you can observe quartz, feldspar, lithic fragments. Okay, quartz, feldspar, and lithic fragments are there. So here you can see 5%. Okay, 5%. That means quartz arenite contains almost 95% of quartz. Okay, it contains almost 95% of quartz, or even more than that. Okay, even more than that. The rock containing 25%. Okay, up to 25% quartz. Okay, feldspars and quartz, it will be called as subarcose. Okay, it will be called as subarcose. Then here, if the lithic fragments are present, right? The lithic fragments are present, it will be called as sublith arenites. This field is for arcose, right? This field is for arcose. This is for lithic arcose and arcosic arenites. Okay, and here lithic arenites. Okay, lithic arenites, right? What is now going into the details of these diagrams? So this Petitjohn classification, okay, this Petitjohn classification, it comprises the textural criteria. Okay, it comprises the textural criteria, and it has the triangular plot that has three components in the end members as the QFL triangle. Okay, QFL triangle. Okay, quartz, feldspar, and lithic arenites. Okay, quartz, feldspar, and the lithic arenites. Right. Now here, if the amount of matrix present is less than 15%, okay, if the amount of matrix which is present is less than 15%, the rock will be called as arenite. Okay, the rock will be called as arenite. If between 15 to 75%, it will be called as vacay. Okay, it will be called as vacay and or vac, whatever you want to prefer. Okay, and if most of the volume of the rock is fine-grained matrix, okay, fine-grained matrix, it will be called as a mudstone. Okay, it will be called as mudstone. So remember these terminologies. Okay, what is ironite, what is vacay, and what is mudstone. Okay, what is ironite, what is ironite, what is vacay, and what is the mudstone. Okay, now quartz is the most common grain type present in the sandstones. Majority of the sandstone contain the quartz. Okay, so only 25% feldspar needs to be present for a rock to be called as feldspathic arenite, arcosic arenite, or arkose. Okay. So 25% feldspar, if the 25% feldspar is there, then the rock will be called as feldspathic arenite because feldspar is present, or 25% feldspar is present, arcosic arenite or arkose. Okay. Now these terms are interchangeable. Okay, these terms are interchangeable. 25% of the lithic fragments in the sandstone make it a lithic arenite. Okay, so lithic arenite, it becomes a lithic arenite. Then over 95% of the quartz must be present for a rock to be classified as quartz arenite. Okay, for if it is called as quartz arenite, quartz arenite, then you must have over 95% of quartz grains should be present. Okay. Now vacays are divided into quartz vacays, feldspathic vacay, and lithic vacay. Okay, quartz, feldspathic, and lithic. So on the basis of the relative amount of these materials. Okay, relative amount of these materials, right? So the term greyvac or greyvacay, you might have heard this term. Greyvac or greyvac has been used in the past for the sandstone. That might also be called feldspathic or lithic vacay. So in the light of this classification, okay, in the light of this classification, we classify these greyvac or greyvacay as the feldspathic and lithic vacays. Okay, so they are typically the mixtures of rocks, rock fragments, quartz, and feldspar grains with a matrix of clay and silt-sized particles. Okay, the amount of silt-sized particles. Right. Okay. Next, we are going. Okay. So the analysis of textural or the terrigenous clastic sediments. Okay. So we know what is clast, what is matrix. Okay. What is the clast, what is the matrix? We know this very well. Okay. We are known to this very well, right? Now there is something called as sorting. Okay. There is something called as sorting. Now what is sorting? Sorting is the distribution of class sized which are present. Okay, which are present. Just like if I have to sort the materials. Okay, if I have to sort the materials, or I have to have a distribution of materials. So what I will do, I will take the same sized materials along. Okay, I'll keep the same size, the larger size materials differently, the smaller size material differently, and even smaller size material differently. okay, at a different places according to their sizes, according to their dimensions. Okay, in the same fashion, okay, in the same fashion, the sorting here in the sedimentary rocks is a description of the distribution of classed size. Okay, classed size. Whichever the class size are present in the sedimentary rock, okay, whichever the class size are present in the sedimentary rock will represent its sorting. Okay, so if in any sedimentary rock, okay, if in any sedimentary rock the class that fell mainly in one class on the wooden Wentworth scale, okay, in a wooden Wentworth scale, if the materials are of same size, okay, not exactly, obviously there won't it is not possible to have a same size material throughout the rock, okay, throughout the rock, but a similar size materials, okay, but a similar size materials in a similar class, okay, in a similar class, if there are only the gravels, only the sand, only the cobble, or only the silt, okay, if such rocks are present, such particles are present, these kind of rocks are called as well sorted. Okay, such rocks are present, such rocks are called as well sorted rocks or well sorted sediments. Okay, well sorted rocks or well sorted sediment, and this is the sorting. Okay, this is the sorting. Now if a range of materials is present, okay, if a wide range of material is present, as it has cobble, it has pebble, it has silt, it has sand, it has mud, okay, it has clay, everything, if all the materials are present, okay, if all the materials are present, it will be, okay, it will be poorly sorted deposit. Okay, it will be a poorly sorted deposit, right? So what is well sorting? Well sorting means it contains only one size of particles. Okay, it should contain one size of particle, that is anything which is from either from gravel or either from cobble, either from sand, either from silt, right? Only one size of material should be there. If it is done, it will be well sorted. If there is a range of materials present, then it will be called as poorly sorted material. Okay, it will be called as the poorly sorted material, and you can see the sorting by the naked eyes. Okay, you need not to go for any high-end scientific method. Okay, any high-end scientific method for classification or for visual interpretation of this sorting. This sorting can be visualized well in the hand specimen. Okay, so what does sorting represent? What does sorting represent? Sorting represents its transport. Okay, sorting represents the transport. See, the sorting is a function of origin and transport history of the detritus. Okay, it represents the transport for how much distance. Okay, for how much distance the particle might have been traveled. Okay, the particle might have been traveled, because if there is well sorting, okay, if there is well sorting, it is like it has traveled a lot. Okay, it has traveled a lot because all the other size particles have been left behind. Okay, have been left behind, and only the similar size particles are now are now getting separated. Okay, are now getting separated, and they are getting deposited, right? Got this? So this is called as sorting. Next comes roundness. Okay, next comes the roundness. Now whenever a particle breaks from the rock, okay, breaks from the rock, these particles looks something like this. Okay, these particles look something like this. Now if you ever try to break the rock, okay, if you even try to break the rock, just take a hammer and try to break the rock. Okay, any rock, anything which is possible, which can be even broken by the hammer. Okay, just break the rock and see the broken particle. Okay, see the broken particle, it will always be an angular fragment. Okay, it will always be an angular fragment. Now these angular fragments, okay, these angular fragments, when they are broken by the natural agencies, okay, these are broken by the natural agencies and they are carried along by them. These particles, they are constantly in motion. right? These particles are constantly in motion. Now, this forward motion of these particles goes for smoothing of its edges. Okay, it occurs the smoothing of the edges like this. Obviously, it requires a lot and lot of traveling. Okay, lot and lot of travel. Okay, so here there are some mechanisms which is called as abrasion, attrition. Okay, there should be abrasion, there should be attrition, there should be collision between themselves. Okay, there should be collision between themselves. Okay, so the first effect is chipping off these angular portions. Okay, these angular portions are chipped off, the angular portions are removed off, and then due to abrasion, there is the rounding of the grains. Okay, there is a rounding of the grains, and the progressive rounding of the edges occur with the prolonged agitation of the sediments, and hence roundness is a function of transport history of the material. Okay, transport history of the material. More round the particle is, okay, more round the particle is, more it has traveled. Okay, more round the particle is, more it has traveled, right? Then comes sphericity. Okay, then comes the sphericity. Okay, I'll show you the diagram here. See, sphericity is an inherited feature. Okay, sphericity is an inherited feature that depends upon the shapes of the fragments which formed during weathering. Okay, which are formed during the weathering. So it is nothing but the how the sediment is broken. Okay, how the sediment is broken. If the sediment is broken like this, it becomes very angular. The sphericity is lower. Okay, it is not. It does not look like a sphere. Okay, it does not look like a sphere. Okay, but as with the transportation, okay, as with the transportation, the sphericity becomes higher. Okay, the sphericity becomes higher, right? This is high sphericity. Okay, this is high sphericity, this is lower sphericity. How the material is broken, that's it. Okay, how the material is broken. Okay, it depends upon the fragment. Well, how the material has been broken during the during its initial stage of weathering. Okay, during its initial stage of weathering, that's it. That defines the sphericity. Okay, that defines the sphericity, right? Next comes this maturity. Okay, next comes the maturity. Now, what is this maturity of clastic sediments? The maturity of the clastic sediments. See, there
By
are two types
sorting.
of maturity. What?
Sorting.
Sorting, no. एक टाइप होता है वो, ठीक है, दो टाइप की मैच्योरिटी होती है, ठीक है, दो टाइप की मैच्योरिटीज होगी. First is textural maturity and another one is the compositional maturity. Okay, first is the textural maturity and another one is the compositional maturity. Okay, what is textural maturity? Textural maturity is when it has a proper texture. That means it has the material. Okay, the material which has the similar kind of particles which are present. Okay, the similar kind of particles which are present, that will be called as its textural maturity. Okay, that will be textural maturity. And compositional maturity means, compositional maturity, that means it has amount of silica. How much amount of silica is present? Okay, how much amount of silica is present? If more than 90% silica is present, it is compositionally matured. Okay, compositionally matured because it has left behind everything. Okay, it has left behind everything which is matrix. Okay, which is just the matrix. Okay, or see this compositional maturity, or it is also called as uh, mineralogical maturity. Okay, it is also called as mineralogical maturity, right? What is? So these are the classifications. Okay, these are the classifications for clastic sedimentary rocks. Okay, these are the classification for the clastic sedimentary rocks or clastic sediments. Okay, clastic sedimentary rocks or clastic sediments. Okay, now we'll move towards another classification, that is for the carbonates. Okay, this classification for the carbonate or the carbonate sedimentary rocks. Next is the non-plastic sedimentary rocks. Okay, non-plastic sedimentary rocks. Majority of the non-plastic sedimentary rocks are generally carbonates, then volcanic clastics, okay, or evaporites, all these things. Okay, so the limestones, you might be knowing about these limestones. Limestones are very much important sedimentary rocks. Okay, non-plastic, very much important non-plastic sedimentary rocks. Okay, so even the top of the Mount Everest. Okay, top of the Mount Everest is formed of the limestone. Okay, it is formed of the limestone. Okay, majority of the structures. Okay, majority of the structures require limestones. Okay, and limestones, when they get converted or they get metamorphosed, convert into marble. Okay, they convert into the marble. Right. So calcium carbonate is the major component. Okay, calcium carbonate is the major component of the limestones. Okay. Just go straight into the classification. The classification of limestones. The classification of limestone. This classification of limestone was given by Dunham. Okay. The classification of limestone is given by Dunham, and hence it is called as the Dunham's classification. Okay, it is called as the Dunham's classification. Okay, so the principal criteria used in this classification scheme is the texture. Okay, it is the texture. Now, what is the texture here? It is described in terms of the proportion of carbonate mud present in the framework of the rock. Okay, so in a rock, if say suppose there is one rock which I am classifying it as a limestone. Okay, when I'm calling it as a limestone, how much carbonate mud is present? Okay, how much carbonate mud is present in this rock? How much carbonate mud is present in this rock? Okay, and on the basis of that, we have, or Dunham has classified the limestones. Okay, now the first stage in using the Dunham classification is to determine whether the fabric is matrix or clast supported. Okay, so whether the matrix is a class supported matrix or the fabric, when the matrix supported or class supported. Okay, now the matrix supported limestone is divided into carbonate mudstone. Okay, carbonate mudstone if it has less than 10% clasts. Okay, if it has less than 10% clast. and wax stone if more than 10% clast. Okay, 10% क्लास से कम रहे तो कार्बोनेट मडस्टोन, more than 10% class रहे तो wax stone. Okay, now if the limestone is clast supported, okay, if the limestone is clast supported, it will be called as pack stone. Okay, it will be termed as pack stone. And if there is mud present, okay, pack stone, it is if the mud is present, and grain stone if there is little or no matrix. If no matrix is present, then it will be called as grain stone. Okay, then it will be called as the grain stone. Now a bound stone has the organic framework such as a coral colony, so there must be some organic framework or some fossils must be present. Okay, some fossils might be present, right? So original scheme that did not include this baffle stone, bind stone, frame stone, everything. Okay. See this. I hope you can able to see. Just a minute. Okay, is it visible now?
Yes, sir.
Yes, sir.
See, this is the Dunham's classification for the carbonate rocks. Okay, Dunham's classification for the carbonate rocks, or specifically limestone. Okay, specifically the limestone. So original component are not bound together during deposition. So here it contains mud, so it will become mud supported, grain supported. Okay, so mud supported less than 10% grain, it will be mud stone. If more than 10% grain, it will be wax stone. Okay, if it is completely if it is grain supported, it will be called as pack stone. If there is no grain, okay, if it lacks mud and only grain supported, okay, if only grain supported, it will be grain stone. Okay, it will be the grain stone. Now more than 10% grains of more than 2 mm diameter. Okay, so it will be float stone if matrix supported, root stone if it is supported by more than 2 mm components. Okay, then original components originally bounded together, deposition means originally bounding will be there. Okay, so it will be called as bound stone. Okay, it will be called as a bound stone. Okay, so now this bound stone is divided into these three: baffle stone, bind stone, and frame stone. Okay, baffle stone, bind stone, frame stone. Okay, so by organisms which act as baffles, it will be called as baffle stone. Which can encrust and bind, it will be bind stone. By organisms which build a rigid framework, it will be frame stone. Okay, and depositional texture, when it is not recognizable, it will be called as completely crystalline. Okay, it will be called as crystalline. Okay. What is so this is the classification. Okay, these are the classifications for the sedimentary, these non-plastic sedimentary, these limestones basically. Okay, this is the classification for the this limestone. Okay, now there are something evaporites. Okay, these evaporites are present. Okay, I'll just give you. In the non-clastics, we have evaporites. Okay, in the non-clastics, we have evaporites as well. Okay, now what is evaporate? Evaporate means something when anything gets evaporated. Okay, anything the salt water or the water gets evaporated, leaving behind one residue. Okay, leaving behind one residue, and that residue is called as the evaporites. Okay, that residue is called as evaporite. Okay, so these are the minerals formed by precipitation out of solution as ions becomes more concentrated when water evaporates. Okay, when water evaporates. So there was water, there was sea water, and that sea water has now been evaporated out. Okay, has now been evaporated out. So majority of these ions, they clustered together, they came together, and they form a mineral. Okay, they form a mineral, and these minerals are called as evaporites. Okay, these minerals are called as evaporites. So these are gypsum anhydrite. Okay, they are the gypsum and anhydrite, the most commonly encountered evaporite minerals. Okay, the most commonly encountered evaporite minerals. So the sedimentary rocks are forms of calcium sulfate. Then gypsum or anhydrite. Okay. So this calcium sulfate is precipitated from seawater once evaporation has concentrated the water to 19% of its original volume. Okay, means when 19% when the water is remaining at 90% of its original volume, the calcium sulfate starts precipitation. Okay, it starts precipitation. Then gypsum is the hydrous form of the mineral. Okay, anhydrite has no water in the crystal structure. Okay, anhydrite has no water in the crystal structures, and it forms either by the direct precipitation in arid shorelines or as a result of alteration of gypsum by burial. Okay. Now, so primary gypsum occurs as elongate crystals of selenite when it forms from precipitation out of water. Right. So these are the different minerals. Okay, these are the different minerals and different materials which are formed out of these materials. Okay, the evaporates. Okay, yes, evaporates. So the important thing in this, okay, the important thing in this is the is your this sedimentary rocks, these clastic sedimentary rocks and non-clastic sedimentary rocks. Now, why clastic and non-clastic sedimentary rocks are so important? Why clastic and non-clastic rocks are so important? Why we are giving much emphasis on the clastic and non-clastic sedimentary rocks and not on the uh, evaporites and other things? Okay, it is because of their groundwater potential. Okay, it is because of their groundwater potential, because the groundwater potential in this clastic rock is highest. Okay, the groundwater potential in the clastic rocks is highest. Okay. Okay, so the groundwater potential of these clastic rocks is highest because you have come across a concept of porosity. Okay, you have come across the concept of porosity. What is porosity? Can anybody tell me?
Number of pore spaces per unit volume.
Porosity is number of voids or number of pore spaces per unit volume. Okay, so if I suppose I've told you about in the classification of terrigenous materials. Okay, in that classification of the terrigenous materials, the roundness. Okay, roundness. What is roundness? The roundness of the particles,
Circularity.
smoothing of the edges, not circularity. These are the original angular grains, right? These are the original angular grains, which will now be converted to grains like this, correct? Okay, which will now be converted to the grains, converted to grain like this. Now, consider the scenario. Okay, consider a scenario when both these two types of clasts or both these two types of materials are making the rocks. Okay, they are converting into the rocks. Okay, they are converting into the rocks. Right. So, if these materials, okay, if these materials they consolidated to form a rock. Okay, these materials are consolidated to form the rock. What will happen? They will fit into each other like jigsaw puzzle, correct? They will fit into each other by like a jigsaw puzzle. Say, this is the unit of rock under my consideration. Okay, under the consideration, and these rocks, these fragments, these angular fragments okay, this is one rock. Okay, this is one rock A. These particles are also making the rock. Okay, these particles are also making the rocks. But here there is well rounding. Can you observe something striking here? In relation with this, let me give you a hint. In which of these rocks porosity will be larger or porosity will be higher?
B.
In A or B?
B.
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 B. Why B? Why in rock B and why not in rock A? Justify your answer.
Because their voids are present.
Because
Void
grains are
space.
interconnected.
B are connected.
Grains.
Grains are interconnected. Okay. In A, there are also void spaces. See? These are void spaces. So क्या इसमें water नहीं रह सकता? These are also void spaces. Then what is so special bit in B that you are answering B? Is its roundness. Okay, is its roundness. Roundness is directly proportional to porosity. Okay, remember this. Roundness is directly proportional to porosity. Okay, angularity is inversely proportional to porosity. Okay, roundness is directly proportional to porosity, and angularity is inversely proportional to porosity. More the angularity, less will be the porosity. Okay, more the angularity, less will be the porosity. Why is it so? Because they become compact. Okay, these when these kind of particles are there, these kind of angular particles are there, they come into contact with each other and they try to fill the gap, right? They try to fill the gap. Now in the diagram B, because it has more rounded materials, okay, it has more rounded materials, they cannot fill the gap between them, right? They cannot fill the gap between these. Okay, even if there is a gap, this gap cannot be filled by any material or any forward projecting edge. Okay, because there is no forward projecting edge, so this space cannot be filled. Okay, this space cannot be filled, and this space which remains vacant, okay, this space which remains vacant here gives rise to high porosity. Okay, this gives rise to high porosity, and hence the sorting again plays a key role. Okay, sorting will again play a key role here. Okay, so if good sorting is there, okay, or well sorting is there, okay, if well sorting is there, it is highly probable, okay, it is highly probable that it has rounded grains. Okay, it has a rounded grains. More the rounded grains, more the roundness is present. Okay, more the roundness is present, more will be the water carrying capacity of any rock. Okay, more will be the water carrying capacity of any rock. So this will be called as, or this will define, okay, this will actually define the porosity. And this is why we are so much concerned, or we are so much interested in the terrigenous rocks. Okay, in the terrigenous rock, or in the um, plastic sedimentary rocks. Whereas in case of the limestones, okay, in case of limestones, what will happen? Limestones generally are compact. Okay, limestone generally are compact. Why? Because they are secreted, because they are chemical rocks, right? They are formed due to the chemical weathering and erosion processes. So they are formed by the layering, and they form as the chemical reactions. They form by the they occur as the compact rocks. Okay, so it is not that much important, or it is not that much possible to incur water from here. Okay, to get water from here, from this limestone. Yes, if the limestones are jointed or fractured, okay, if the limestone is jointed or fractured in the joints, okay, in these joints, if the joints are open, okay, if the joints are open, then it may contain water. Okay, it may contain water, or it is fractured, it may also contain water. But yes, these water will be limited. Okay, this water will be limited. This fractured and jointed nature of the limestone, okay, will be secondary porosity. Okay, it will be secondary porosity in the igneous rocks. Okay, in the igneous rocks, in the Deccan basalts. Okay, in the Deccan basalts, what we encounter is this secondary porosity. Okay, is this secondary porosity, because we don't have water in there. Okay, we don't have in basalt. This basalt is so compact. Okay, this basalt is so compact that water cannot infiltrate. Okay, water cannot infiltrate. So water goes inside wherever there are voids. Okay, wherever there are voids or if there are fractures. Okay, if there are fractures and water gets accumulated here. Okay, water gets accumulated here and forms the reservoir. Okay, and form the aquifer. So these are the aquifers which are present in the basaltic terrains. Hence, the areas, okay, hence the areas which are lying near the basaltic terrain or the igneous terrain, they always lack groundwater. Okay, they always lack groundwater. Okay, whereas the areas which lie near or at the sedimentary terrains, and that too clastic sedimentary terrain, they will always have higher groundwater potentials. Okay, they will always have the higher groundwater potential, just like the areas which the people living near the rivers. Okay, near the rivers or near these kind of sedimentary terrains. Okay, in the sedimentary terrains, so they have large amount of water. Okay, they have large amount of water because they have aquifers. Okay, they have aquifers in their areas. Okay, they have aquifers in their areas so that these aquifers are productive. Okay, these aquifers are productive, they can yield much amount of water. So this is the relation of porosity and angularity. Okay, I hope you understood this, the relation between porosity and angularity. What is the relation between porosity and angularity?
Angularity is inversely proportional to porosity.
Angularity is inversely proportional to porosity, right? More will be angularity, less will be porosity, right? More will be porosity, less will be angularity. Okay, or less shall be angularity. And roundness, right? Roundness is directly proportional to porosity. More the roundness, more the porosity, right? What is all these things? So these are the classifications. Okay, these are the classifications which are given in this syllabus, right? So we'll stop here today itself. Okay.